Okay, I want to summarize a little bit about conversions, specifically focused on mass, mole, and particle conversions. So first, let's just go through kind of a summary of what we have available to us, and then we will do some examples. Um, so there's a lot of different tools we can use, but I'm going to go through 6 kind of main conversion tools that you should be familiar with. So first off, metric prefixes. You can look up tables that tell you what different metric prefixes mean, what exponents they relate to, and when you look up those tables of values, they're going to give you a link between the base unit and the unit with a prefix. Okay, and so you can build conversion factors from that information about metric prefixes. And you should be able to convert from any unit to any prefix with that unit, or a prefixed unit to the base unit. Using that information about prefixes. Now, another kind of basic piece of information you have that you can utilize to do conversions is density. So density is just a ratio of the mass to the volume of some particular substance. And so you can utilize that ratio to convert either from mass to volume of that substance or from volume to mass of that substance, as long as you know the density, okay, and you know one of those two things, you can convert. Another thing that tends to get overlooked is chemical formulas. So just having the chemical formula of a substance, so knowing what you're dealing with, can give you actually a lot of conversion factors. And so it can give you conversion factors that relate the individual atoms within that substance to the molecules that make up that substance, or the other way around. You can convert whichever direction, or if you're talking about an ionic compound, it relates the number of ions to the number of formula units, okay? Just by having the chemical formula. Now, another thing that we can use to do conversions is Avogadro's number. So Avogadro's number, we'll use 6.022 times 10 to the 23rd, so we'll use it for sig figs. That is the number of particles in a mole of something, okay? And so that can be used to jump between the number of particles of something and the number of moles, okay? So whether or not you know the particles and you want to convert it to moles, or you know the moles and you want to convert it to particles, doesn't matter, you always use Avogadro's number in that case. Another thing is molar mass. So molar mass, you can look up on the periodic table, okay? So you can look it up directly for specific elements, for atoms of those elements. If you have a compound, you can look up each individual element that makes that up and multiply it by however many atoms you have of each, and sum things together to get the molar mass, and that's going to give you a link between the mass of something and the number of moles, okay? And lastly, percent composition, or sometimes we just call it mass percent. If you know the mass percent of something, or you quantify the percent composition of something, you can utilize that to relate the total mass of that substance to the individual components masses in that substance. Okay, so these are just 6 really, of the major tools we use. They're kind of the basic pieces of doing conversions in chemistry. Okay, of course, there's always more stuff that comes up, but this is kind of a foundation. It's assumed that you know that you can utilize these things for any problem that you need to do these types of conversions. Okay, now sometimes the information you need is directly given, like say a density may be given to you, so it's a little more obvious that you have that tool at your disposal. But some of this stuff like density or molar mass, you may need to look up in order to then apply it. Okay, so let's do some examples of using, multiple of these in one problem. So instead of doing one-step conversions, let's look at multi-step conversions. So more complex ones that are comprehensive. They contain at least two of these things that we're going to apply. So let's see. Here we've got a couple examples. We'll start with this first one that says calculate the number of calculate the number of atoms in 25 grams of lead. Okay, so you can try to list things out and come up with a plan. I'm going to talk through the plan as we go. I'm always going to start with what's given. You know, if you're only given one number, you have to start there. So that's why I'm not going to list things out. So we only have one number, so it's a little more clear where we need to go from here. We have to start with that. So we're going to start with 25 grams of lead. So G for grams, and lead is PB. Okay. And I definitely know, so I'm always going to be doing dimensional analysis. I definitely know I don't want grams of lead, right? That's not my end goal. Okay. So I'm going to go ahead and write that in. And I have to convert grams to something. Now, what we're looking for is the number of atoms, okay? So you could potentially write atoms of lead up here, right? But then think back to those conversions I had on the slide before. There was nothing that said that you can convert between atoms and grams, okay? Now, you can kind of figure out a conversion factor between those, but I don't know, when people try to do that, a lot of times I see people make mistakes. So I wouldn't do that. So we don't have a direct link to atoms. So I'm going to erase that and know that eventually I still want to get to atoms, okay? But at the moment, I'm not going to do that. I'm going to think about, okay, well, my end goal is atoms. What can I relate to atoms? Well, what I can relate to atoms is moles. Okay, because remember, Avogadro's number can link between moles and the number of particles. Atoms is the number of, or is the particle we're dealing with. So then the question is, can I get grams to moles? And the answer is yes. Okay, so I can first go from grams to moles of lead. And so I need something that relates grams and moles, and that would be the molar mass. Okay. So then I would go to the periodic table and look up the molar mass of lead. And what you're going to find is 207.2, and that goes with the grams. So there's 207.2 grams per 1 mole of lead. Okay, so that's one of the few on the periodic table. It doesn't give you more than 2 decimals, or 1 decimal, so you can't, keep more, and that's okay. So we'll keep that. So that's going to cancel my grams of lead. And now I want atoms. And so I want to go from the moles that I have, I want to cancel that, and I want to go to atoms of lead. And then the question is, can we do that? And the answer is yes, because atoms are particles and moles are, we can relate, moles and atoms using Avogadro's number. So there are 6.022 times 10 to the 23rd atoms of lead in 1 mole of lead. Okay, so then I can cancel my moles, and that's going to give me what I'm wanting, is the number of atoms. So I'm going to take 25.0, I'm going to divide it by 207.2. And then I'm going to multiply that by 6.022 times 10 to the 23rd. And it's helpful if you use the scientific notation button on your calculator to type this in, okay? You use that EE or EXP button, you just type 6.022 and then hit the EE or the EXP button and then the 23. Makes things a little quicker and less errors if you're not following order of operations properly. Okay, so now I want my answer. I'm not going to write down everything that's in the calculator. I'm going to look at my sig figs. 25.0 is 3 sig figs. The 207.2 is 4 sig figs. And Avogadro's number that I use is 4 sig figs. So my limiting factor is the 3 sig figs. So in the end, I'm going to round to 3. So 7.27 times 10 to the 22nd. Okay, and that's atoms. Okay, and so that would be my answer. Sorry, that 10 is kind of messy. Okay, so that's that one. Now the next one says, what is the mass in grams of 2.35 times 10 to the 22nd formula units of lead to bromide? Okay. So I only have one number given to me, so I'm going to start with that. Okay, so 2.35 times 10 to the 22nd formula units. So I'll write form unit PBBR2. Okay, that's what I have. And I don't want formula units, so I'm going to write formula units, abbreviate it, lead to bromide. Okay, and then I want mass, right? And so initially you might write grams of PBBR2, but then you stop and think, okay, well, what numbers can I fill in here? Well, in my kind of conversion summary on the previous slide, or the previous slide, there wasn't anything linked grams and formula units. Okay, just like the one above, you can come up with a relationship, but I would suggest not doing that because I see people make mistakes when they do that. So I would go to something we know we can relate it to. So formula units are our particles of an ionic compound. Okay, and we can always relate the number of particles of something to the number of moles of that thing. Okay, and so that link is Avogadro's number. So 1 mole of something is always 6.022 times 10 to the 23rd of that thing, okay, of the particles of that thing. So my formula units are going to cancel. And now I want grams still. And I have moles, so I'm going to cancel those moles. So I'm going to put them opposite. And I want grams. And so I'm going to write grams in the empty slot. And then stop and think about, can we relate grams and moles? And the answer is yes. You use the periodic table. So you're going to look at the periodic table. And your lead is 207.2, right? 207.2 grams per mole. And bromine, there's 2 of those, and each individual one is, I believe, 79.90 grams per mole. And so that's going to give me the molar mass. So 2 times the 79.0 plus 207.2. And so that gives me 367.0 grams per mole. And oops, back. Go. So I'm going to put that in here, 367.0. I rounded to 1 decimal because of the lead. Okay, so that's going to cancel my moles and give me grams. Okay, so I'm going to erase this molar mass calculation because I need room to write my answer. Okay, so 2.35 times 10 to the 22nd. I'm going to divide by 6.022 times 10 to the 23rd. Okay, and then times 367.0. And our ending value should have 3 sig figs because of the given information. So that comes out to 14.3 grams of PBBR2 as our answer. Okay. Okay. So in those two, we used Avogadro's number and molar mass to jump between grams and particles. Okay. Because you can't directly go from grams to particles or particles to grams, but both of those you can link to moles. So you jump to moles first. And that's pretty common in solving a lot of chemistry problems. Moles usually is the thing that we can link to about everything that we want to know. Okay, so very often, if you're not sure what to do, convert whatever you're given to moles. And then think again if you have any other ideas of how you can get to the end goal. Okay, so very often, first thing you should do is convert to moles, unless if you already know for sure that you should do something else. Okay, so let's look at a couple more. Here I say how many hydrogen atoms are in a 75 gram sample of C6H12O6, which would be glucose. Okay, so again, we're only given one number here. So I'm just going to start with that one number, 75.0 grams. Okay, and that is C6H12O6. Okay, and I want to know how many hydrogen atoms. So we'll start off our dimensional analysis and we'll write grams of C6H12O6. And you might initially say, okay, well, I want atoms. Oops, that's not good. There we go, atoms, hydrogen, right? And then you stop and think, well, how the heck do I relate those? Well, you don't have a way to relate hydrogen atoms directly to grams of some compound. Okay, so I'm going to erase that top. That's not what we want. Okay, so I have to think about what can I relate a mass of a compound to. And like I said before, if you don't know what to do, probably your best bet is to convert to moles. Okay, so that's what we're going to do. We're going to go from grams of C6H12O6 to moles of C6H12O6. So that we can do by using the periodic table. We just look up the masses of these things. Okay, so 6 times 12.01 grams per mole plus 12 times 1.01 grams per mole, and then 6 times 16.00 grams per mole. We add all of that stuff together, and that's going to give us our molar mass. If you add all of that together, you should get 180.18 grams per mole. Okay, so that information then gets plugged into that ratio. So there's 180.18 grams in 1 mole of that. So that's going to cancel my grams. And then I can get rid of moles of C6H12O6. And then again, looking at what we want atoms of hydrogen. Then the question is, can I go from moles of some compound to atoms, of an element within that compound? And no, we don't have information to do that directly. So let's try to get closer to that, okay? So what can we relate to atoms is the question. And hold on, try to erase this. Maybe won't let me erase it. I will just cross it out. There we go. So what can I go to for moles of this compound that will help me figure out how many atoms? Well, I should be able to relate the atoms to the molecules, right? Because if I had 1 molecule of C6H12O6, I would have 12 atoms of hydrogen. The chemical formula tells me that, right? And so I could go from moles of C6H12O6 to molecules of C6H12O6. Okay. So 1 mole of that should be, sorry, I'm running out of room here, 6.022 times 10 to the 23rd of those molecules, right? It's going to cancel my moles. And now I should be able to convert my molecules of C6H12O6 to atoms of hydrogen, okay? Is that information I get from the chemical formula? There's 12 atoms of hydrogen for every 1 molecule of C6H12O6. So that would cancel then my molecules and give me hydrogen atoms. Okay. So if I did that, I'd take 75, I'd divide by 180.18. It would multiply by 6.022 times 10 to the 23rd. And then I would multiply by 12. Okay. That would give me an answer of 3.01 times 10 to the 24th atoms of hydrogen. Okay. Hydrogen atoms. You can write it the other way around if you want. So that would be my answer. Now, you could go a little bit of a different route. That happens a lot in chemistry. Okay, so there's not always only one way to solve a problem. So instead, I could have used, from here, so this beginning part, I could have taken that, and then I could have multiplied by that for every 1 mole of C6H12O6, I could have said that I wanted to relate that to moles of H. There'd be 12 moles of H for every 1 mole of the compound, right? And then I could convert moles of H to atoms of H using Avogadro's number. Okay. And if you added those 2 steps instead of the 2 that I put initially, you would end up getting the same result. Okay. You're just kind of doing it in almost a reverse way. You're doing this in a little bit different pathway, but in the end, all the steps are really the same. Okay. You would get the same answer. Okay. Now let's look at just a couple more. So let's see. Now I have what is the mass of chlorine in a 17.5 gram sample of sulfur dichloride. Okay. So again, I only have one number, so I'm going to start with that one number. So 17.5 grams of SCl2. Okay, so I definitely want to cancel grams of SCl2, and I want mass of chlorine, so we'll say grams of chlorine. And then you can stop and think, well, can I do that? Do I know how to relate the mass of some element to the mass of a compound that it's in? Well, the answer there is yes, you could do that, but you need the mass percent of chlorine in that compound, okay? So you could stop and calculate that and then put those numbers in. I'm going to go a different route. So that's one option, but since I wasn't given that information, I'm going to choose to try a different route, okay? If you want to see that calculation, you can look at the percent composition video, and I'll show you how to do that. So let's look at doing something different. If instead I didn't think of that I can convert directly between the grams of the substance and something contained in it, then I'd say, well, if I don't know what else to do, I'm just going to convert to moles. So let's try that. If we just convert to moles of SCl2 and then think about what else we can do. So to do that, I need to look up the molar masses. So I would have 32.07 grams per mole for the sulfur. And then I have 35.45 grams per mole for each of those chlorines. So I would multiply that value by 2. And then I'd add all of that together. Okay. And so let's see what that gives us. 32.07 plus 2 times 35.45. And that gives me 102.97. Okay. So 102.97 grams per mole. So that value I'm going to plug in here. So 102.97 grams for every 1 mole. And then I can go through and convert my moles of SCl2. I can convert that to moles of chlorine, And that'll get me a step closer to the end goal, right? Because I want grams of chlorine, but I can't go from moles of substance to grams of something in it. I would have to find out how much of that thing I have. Okay, so from the chemical formula, I can say that 1 mole of that compound contains 2 moles of chlorine because there's a subscript of 2 with the chlorine. Okay, and then from there, I can convert from moles of chlorine to grams, of chlorine. And that'll get me to what I'm looking for. And 1 mole of chlorine is 35.45 grams. That you get from the periodic table. And so this setup cancels my grams, cancels the moles of SCl2, cancels the moles of chlorine, and gives me grams of chlorine, which is what I'm wanting. So I'm going to take 17.5, divide by 102.97 times 2 and times 35.4. And that gives me 12.0 grams of chlorine. Okay. Now, you could also, like I said, you could directly convert from grams of SCl2 to grams of chlorine if you had the mass percent of chlorine in that compound, okay? And you can check, you can calculate the mass percent of chlorine and then do this calculation with that, and you should get the same result. Now, you may be off by a decimal place depending on how things are rounded differently, okay? Within the work, if you round, it's always going to throw things off in that last digit a little bit, okay? And so that's why when you're doing calculations, you want to always try to either leave everything in the calculator or keep an extra decimal or an extra significant figure, I should say. Okay, let's do the next one. What is the mass of a sample of lithium phosphate that contains 1.85 grams of lithium? So again, we have one thing given, so I'm going to start with that, 1.85 grams of lithium. Okay, and then, well, we can stop and think about this. We want to cancel grams of lithium, and we want to go to grams of lithium phosphate. So when you look at this, you have a ratio of masses. And the only place you can get a ratio of masses is from a mass percent, or the percent composition of that particular element, that compound. You weren't given that, so I'm not going to go that route. You are more than welcome to stop and calculate that and then plug that in. But I'm going to go a different route. So I'm going to go the way that when you're unsure, this is probably what you should be doing, right? If you don't know what to do, remember, as I said before, just convert to moles, okay? So we're going to convert to moles first. We're going to convert from grams of lithium to moles of lithium. We do that using the periodic table. So you look up lithium, what you're going to find is its molar mass is 6.94 grams per 1 mole. Okay? And then I'm going to convert between moles of lithium and moles of the substance I'm looking for simply by using the chemical formula. So you can jump between the compound and any piece in that compound just using the chemical formula, and you can make a mole-to-mole ratio out of that. So I would look at that chemical formula, and for every one of those, I have 3 lithiums because it has a subscript of 3. So that gives me my mole-to-mole ratio, okay, to break apart that compound or to recreate it. Okay. Now I would have moles of lithium phosphate, and I want the mass, so I'm going to calculate grams. So I'm going to get rid of moles of Li3PO4, and I'm going to go to grams of Li3PO4. And so then I just need to add everything up. So I'm going to have 3 lithiums, so 3 times 6.94 grams per mole. And then let's see, what else do we have? Phosphorus, so 30.97 grams per mole. As always, these are coming from the periodic table. And then 4 times 16.00 grams per mole for the oxygen. And as always, as I've said, always try to keep at least 2 decimal places from the periodic table. Otherwise, you're going to integrate in a lot of excess error. Then you're going to add these together. And when I say keep 2 decimal places, if you're going to, drop stuff, remember that you're rounding things. That's why you see me write down 16.00 for oxygen, because what's on the periodic table is 15.9994. And so that rounds to 16.00 if you're rounding to 2 decimals. Okay. So now we're going to take that, we're going to add that up. 3 times 6.94 plus 30.97 plus 4 times 16, and that gives me 115.79. Oops. Grams per mole. Okay, so that molar mass, oops. Oh, let's get back in now. It's my spot here. Okay, so that gives me my molar mass. I'm going to put that in here. So that would be 115.79 grams per 1 mole. So I'd take 1.85, divide by 6.94, and divide that by 3, and then multiply by 115.79. And so for that, I get 10.3 grams of lithium phosphate. So I rounded that to 3 sig figs because the 1.85 only has 3 sig figs, which is the fewest in my calculation. Okay, so that's it for some kind of review of some basic unit conversion type problems that we have. Okay, so it's not just converting a mass unit to another mass unit, or a volume unit to another volume unit, things like that. You can convert between different types of quantification, so between masses and just amounts of particles, things like that, using all of these different tools that I introduced at the beginning.